Yes, dear student, now I will discuss in detail isothermal process and adiabatic. So first of all, here I have taken isothermal process. I have written in advance to save time. When a thermodynamic system undergoes a physical change in such a way that temperature of system remains constant or does not change, then the process or change is called isothermal process. I mean, when any thermodynamic system undergoes a process or a change, physical change in such a manner, temperature does not change, then that is called isothermal process. Now, when process takes place in isothermal system, some heat may be produced or may be absorbed by it, and in last chapter we have learned that when heat is given out by system, its temperature may decrease, or if heat given to substance, temperature may increase. So, for such a process to take place, the system should be surrounded by an atmosphere, surrounded by such a material which allows the heat come in or go out of the system. So that temperature does not change. I told you thermal system, generally we use a gas, ideal gas in a cylinder enclosed by piston. Here, suppose it is gas, and if it is enclosed here and some pressure is there, if we decrease pressure, gas will expand. If it will expand, it will do some work, P delta V. That work will be done on the cost of internal energy. And if internal energy consumed, the temperature may decrease. So, this surrounding, this material of the piston should be perfectly ideal conductor, so that whatever the loss of heat takes place, the same goes in. Now, if we compress the gas by increasing pressure, then work will be done and internal energy will increase, temperature will increase. So, to keep the temperature constant, heat should go out. ये लिखा हमने यहाँ पर कि the system should be surrounded. Here the ideal gas is system. So whatever the heat produced, that goes out, and it means it's the surrounding. Hence, the surrounding material should be a sorry, but perfectly talking, there is no but there is no material which can instantly allow the heat to go out or come in so quickly. Then what is the option to do if the process takes place very slowly? Then it can be, or then the isothermal process may be supposed taking place to take place. But theoretically, condition is not that any process which take place slowly. Basically, theoretically, the process or the physical change in system which take place at constant temperature, that is isothermal. So, the isothermal, sorry, so the isothermal process is a theoretical idea. Now, no process can be practically isothermal. No process can be practically isothermal. But under isothermal chain, the ideal gas in isothermal chain, isothermal process obeys Bayes' law. I will be teaching Bayes' law later, but you may know it. That is pressure into volume. That is pressure into volume of gas constant. Condition क्या है? At constant 4. a given mass at constant temperature. At constant temperature, given mass of gas, P will remain constant, P pressure, V volume. So this is something about adiabatic process, reaction process. Now I come to adiabatic process. Adiabatic. Process. To understand thermodynamics, this is very important to understand the meaning of adiabatic and isothermal and the condition under which they can take place and how do the variables of thermal system change under these. So what is adiabatic process? Yes, if a thermodynamic system undergoes a process or a change. Change means variable like pressure, volume, temperature. In such a way that heat is neither allowed to come out of system nor to come in the system, then the process or change is called adiabatic. Adiabatic process or adiabatic change. Adiabatic change. Dear friends, these are very simple topics and very important in every exam. These problems based on these are asked. And I am sorry to say, I checked once, 2 times the copy of PMT. A student did not attempt thermodynamics, did not attempt. I saw that students were not able to attempt thermodynamic problem. Very few students were there. They remain involved only in mechanics, work, power, energy, force, and sometimes in electricity, current electricity, electrostatic only. And the simple topics actually remain untouched. And I'm looking here also that initially student took very good interest in my videos, but now I'm getting very small number of views and the hours for which was. But I request all of you to go through. Now how to perform adiabatic process. for this process to take place, system should be inside a surrounding. Yeah, system should be surrounded. System to take place, system should be surrounded by material which is perfectly bad conductor of heat. Bad conductor of heat. But you know, we have very bad conductor of electricity, but ideal bad conductor for heat are not available. The wood, which we say bad for heat, does not completely avoid the loss of heat. The loss of heat can take, I have told you, can take place through convection also, radiation also. Then it means how can you perform? But no material is there which is perfectly a bad conductor. So how to perform if the process takes place very quickly, so that heat does not get time to come in or go out. Then adiabatic process. Can be performed. But this is not again a condition. The condition is only that if the heat neither allowed to go out nor to come in. But this is not theoretical condition. Any process which takes place quickly, the expansion or compression of gas takes place quickly. That is the adiabatic. No, adiabatic is that in which heat is allowed to come in or go out. But this is not the theoretical condition for adiabatic process. So condition though is only that it should take place in such a manner heat is not allowed to come in. Now during adiabatic process. Ideal gas obeys Poisson's equation. That is PV to the power gamma is equal to constant. P pressure, V volume, gamma Cp upon Cv. Ratio of molar heat at constant temperature, constant pressure. Now using equation PV equal to RT, we get here, T into V to the power gamma minus 1 constant also. From here you remove now P barabar RT upon V, put it here, you will get it. And T upon P to the power gamma minus 1 also constant. What it means? Actually it means, and this means P1 V1 to the power gamma equal to P2 V to the power gamma equal to P3 V3 power gamma, and so on. Similarly here T1 V1 to the power gamma is equal to gamma minus 1, sorry, I mean gamma है, sorry, TV की power, हाँ ठीक है, equal to T2 V to the power gamma minus 1, and so on. Same thing is there, P1 upon P1 to the power gamma minus 1 equal to P2 upon, because you will get many problems based on this equation. So this was about isothermal and adiabatic processes. Now I will take further more topic like isothermal and adiabatic curve, and will find the ratio of their slope.